Hi, another bit of medical kit to tear down today. This is an implantable cardiac defibrillator for people with heart conditions. They implant this thing. If it detects an abnormal rhythm, it zaps it with a voltage to get it going again. So made by a company called Medtronic, InSync 3 Marquis, and helpfully it actually shows the connections on the back. I'm guessing RV, maybe right ventricle, LV left ventricle, A aorta perhaps. Not sure about the other two. So this metal can, I'm guessing this is probably titanium, because I believe titanium's got very good biocompatibility. It looks like it's been welded around the outside. This case looks like it's been welded. I'm guessing it's probably been laser welded, certainly some sort of robotic automatic process to produce a nice clean weld all the way around the edge. This top piece is for connecting the various electrodes. This is made of a clear plastic, and it looks like the top piece and the defibrillator case are made in two things, and then there's these welds. So I'm guessing each part has wires coming out of it, then they're welded together, probably with an ultrasonic weld or maybe a resistance weld onto these panels. It's supposed to see these terminals. These are actually screw terminals, and there's some soft silicone here that you can actually get an Allen key through to actually get to the screw. Not sure if we can focus on that. You might actually be able to see the screw at the bottom of that cavity if I just unscrew it. These three connections on the right are just single pole, but it looks like these left-hand ones are for coax. There's like there's an outer sleeve and then an inner electrode here, so there's probably a shielded connection or just a two-pole connection on some sort of coaxial cable. And this top block seems to be pinned on. This one does actually show evidence that it may have had a previous owner. There's some remnants of some sort of biological goo in there. This is I'm guessing this hole is maybe for attachment. Maybe they cable tie it into the rib cage or something. I don't know. Doubt if they want it just slopping about. So I'd imagine there's some attachment. So I think we need to get the Dremel out to crack this thing open. I've cracked it half open so far. There's some insulating there. This looks like capped on this part of the can. There's what looks like a coil here. This is probably an induction loop for communication, so that this thing can be set up by using a coil held outside the patient to set the parameters, do data logging and monitoring and so on. And the connections to the main boards, they seem to have got these sort of blocks which I think look like the surface mount, and then these have been ultrasonic welded onto this flex on the back. Not quite sure what's going on here. There's this piece of metal at the bottom end looks like it's welded to the case, and then there's this connection that's welded to that. Now I don't know whether that's just an earth connection or maybe some sort of antenna or something. And this zigzag could simply be for flexibility, so that this thing could come out and flex a little bit without fracturing, so not quite sure about that yet. These are the connections through to the outside Basically the other side of these are just going to be some sort of seal, so the wire sort of feed through seal. There's probably maybe some RF filtering in there as well, because obviously it's quite important that these things aren't susceptible to like mobile phones and other magnetic fields and RF interference. So there's going to be a seal up there, but I think these could just be sort of filters. We'll have to pull those apart to. The other side of the can does seem to be fairly well glued to this plastic carrier, so I think we'll go in from the top and see what we can find from this side. I'm just going to snip off these welds that are holding this bit of flex PCB down. Ooh. Interesting. It doesn't like that. Now, what are you supposed to do if your pacemaker starts making noises at you, I wonder? It's not happy, is it? I think maybe we'll try and find the battery wire and snip that. I'm guessing this is the battery connection here. Maybe not. Right, so this top flex, it's got this antenna coil around here. It's also got a piezo sounder, so that's what was making that noise. And in here we can see lots of very small IC packages. These are the sort of, you can just see the backs of the chips here, and these will be BGA packages down onto the main board. And you can see there is quite a lot in here. There's lots of capacitors and a surprisingly large amount of silicon. And these are some pretty enormous pieces of silicon really in terms of chips. And that big one there is, and that big one there is 10mm wide, and that's a hell of a bit of silicon really. For something like this, I'm just curious as to why. I suppose maybe if it's defibrillating, perhaps these are maybe high voltage switching devices or something. But in terms of just sort of like general processing and so on, I mean, those are absolutely huge. Right, I think these two large things at the bottom are actually the high voltage capacitors rather than the battery. There's no voltage measured across them, but I was measuring 2 volts across these two terminals here. Just measure these. Yeah, I measure about 185 microfarads. Not sure what voltage these run at. Obviously an external defibrillator uses quite high voltage. It's got to get through quite a lot of skin. This thing's going to be connected pretty much directly to the heart, so I would imagine that you need rather less voltage to do its thing. Not really sure what voltage that is though. Just going to try and dig some of this plastic away. This bottom section is pretty well glued down, so I think I was going to just try and hack all this plastic off, because I think this PCB is stuck down as well, so it might take a bit more digging to get further into it. Just looking at how these are wide, these appear to be wide in series. whether that's just to increase the voltage rating or whether maybe it can decide whether to use one or both of them, or maybe it does bipolar waveforms or something, I don't know. You can see those sensor positive and negative ones go to the same bar. This is just a sort of piece of moulded plastic. Seems a quite convoluted way of just getting these wires around the corner, but obviously it's obviously a very compact unit. The other thing to notice is that almost all these connections are welded rather than soldered. Obviously that's for reliability. Probably they may well be all sort of machine robot welded as well. Right, I've got most of the plastic off. I've got these two capacitors off. These seem to be a sort of welded aluminium case. This denting is just the damage I did in the process of getting them off because they were glued in, so it's peeled the case open a little bit. The rest of it, so we've got this board on top and then this back bit, which is the battery. There's another piece here, I'm pretty sure that's going to be the transformer for stepping up the voltage. It's like in a shielded metal can. I'll tell you, this is the battery, that's the terminal coming out of the battery. Measures 2.6 volts. I'm guessing this is probably a lithium battery of some sort. Just see how much current it can put out. It's quite a lot. It's about 7 amp short circuit current. So I don't really want to be shorting that for too long here. Might try that outside later. Now there seems to be quite a lot of this black potting compound around here, so it might be a bit tricky to get any further into this, but we'll have a go. And yes, this does look like the high voltage transformer. We've got some like a toroidal core with some chunky windings there, and you can just see some finer windings underneath it. Right, I managed to peel the battery off this PCB. Unfortunately the back side is potted in some pretty hard potting compound, so it's going to struggle to do anything. I just peeled this back a little bit and it's peeled off another couple of large silicon devices. I can imagine that some of these are probably power devices, like high voltage power devices, hence the large size. And the PCB itself has got, I'd imagine, probably 6 to 8 layers. You can see a few odd little bits of, sort of edges of layers poking out the side. And the vias seem to be sort of buried vias as well. They don't go all the way through the board, they sort of don't go up to the top. Very, very small. These may be laser drilled vias, they look extremely small. I'm not quite sure what this is. I think might perhaps be some sort of filter. If that sensor piece is ferrite, then maybe it's just some sort of common mode filter or something for RF interference. The rest of the parts, you've got obviously tantalum capacitors here, ceramic caps. I think these might actually be tantalum caps as well because of the markings. There's a few of these resistors which have got these little cuts in them, which are laser trim resistors, so the values are actually trimmed by a laser after they've been assembled onto the PCB. Guessing that's probably a crystal there. I might try a bit of heat. These all these chips have got this underfill, which is quite a hard sort of adhesive. I might try a bit of heat to see if I can soften that up and just peel the chip off, just to see if it's a chip or a large FET or something. This is the inside of one of these capacitors. I think it's basically an unrolled electrolytic. It certainly smells quite similar to the insides of a standard electrolytic. So, but obviously because of the form factor, they've just used flat plates instead of rolling them up into the normal cylindrical form factor. You can see the the multiple parallel plates. So these plates are all connected in parallel to each of these electrodes. So it's fairly conventional tech, just in a slightly unusual shape. Right, this potting compound seems to be extremely tough. One of my usual techniques for attacking this stuff is to put it in some dichloromethane based paint stripper for a couple of days, and most epoxies it tends to soften and swell it. This has been in there for a couple of days, although the weather's been quite cold, but it just seems to have no effect at all. So maybe it's something else other than epoxy, or it does seem to be very heavily glass filled. There's a slightly sparkly look to it, so this is a very, very tough potting compound. I wonder if maybe this is perhaps to help with high voltage clearance or something. There's the backs of some semiconductor devices here, so maybe perhaps all the high voltage switching is actually on this side. But I'm still very curious as to these enormous chips. I think what I might do is if I can find some fresh dichloromethane and leave it for a while, because if you leave it long enough it will actually delaminate the PCB itself. I would quite like to get a look at the tops of these chips, just to look at the pin counts and so on, and also get some idea of the layer stack up of this board, because it's obviously an extremely high density. And certainly I did try using hot air to soften up this lacquer and soften the potting compound, but that didn't really work. Obviously it's unsoldered all these chips in the process, but it seems to be a very, very tough bit of circuitry, so I think it might need a bit more more sustained attack. Right, this PCB has now been sat in proper epoxy stripper, which I believe is dichloromethane and methanol. This has been sat there for about 3 weeks, and we've got a bit of movement. A couple of chips just popped off. I think what's happened is that the PCB itself has started to swell. This epoxy I think has also swollen a little bit around the edges. It was a bit soft and I managed to crack a few bits off, but I think it's just the curvature of the PCB has just cracked that chip off. It's a little bit hard to see exactly how this is mounted. I mean, there's one over here where it looks like it's been wire bonded. It's either been wire bonded or the actual chip, yeah, it's actually got bumps on the chip directly onto the PCB. I think I have to strip it down a bit more to figure out. A lot of these devices here appear to be power semiconductors. I'll stick them under a microscope in a minute to take a closer look, but you can see from the structure that they're sort of FET or something similar rather than ICs, because of the level of detail. And there seems to be this sort of thin material. There's these sort of substrate pads. I'm not totally clear whether this, I think this may even be the top layer of the PCB material. You can see here, for example, you can actually see the weave of the fiberglass material where the top layers come off, but because the epoxy stripper has taken off sort of a lot of it's mostly the PCB it's taken off rather than this epoxy, so that when I sort of crack a little bit off of here, I think it's tending to take the top layer of the PCB off with it rather than just crack the epoxy. We see that this is that big chip. There's quite a lot on it, so we'll try and get a close look at that under the microscope. And there's just a few of the fragments where the epoxy's come off and taken the chip off. None of these chips seem to be packaged to any significant degree. They all seem to be pretty much bare die onto the board, and so I'm not totally sure if they're sort of bump pads on the die onto the PCB or whether they've got bond wires, or maybe there's some combination of the two. So we'll take a close look at those, and then also I'll see if I can crack a little bit more off this, but I suspect it might take a bit more chemical attack before this comes right off. And on this one you can actually see, I'm guessing this is probably a FET or something, you can actually see a bond wire going from the device down to the board. So this is, again, it's a bare device that's been put on the PCB and then bonded on to connect it. There's no obvious features on this surface. This is probably just one fairly large area of, say, maybe a diode or a MOSFET or something. Here's a close-up of that chip. It looks like it's something like a MOSFET. It's very simple features. This is one of the other chips. There's quite a lot of different features here. It's not really clear what this is. There aren't any big chunks of memory or anything. There's a few areas that look like they may, here for example, look like maybe gate arrays, but then there's those odd-looking large sections, and as you go around the chip there's just all sorts of very different looking features. Maybe these bits on the right are perhaps output drivers or protection circuits or something. They seem to be quite big features. But there's a lot, quite a lot in this. And this chip, like most of the others, does actually have copyright Medtronic on the die itself, so these look like they're pretty much all custom chips. I think this is probably a memory, and it looks like it has a much smaller feature size. There's a lot of chips like this which have very big features. Maybe they're just, you know, groups of discrete semiconductors or fairly simple devices. There's another one. This is another fairly complex chip, again, a variety of different looking features on it. Here's another very low density device. And this is a what looks like a high density. I'm guessing this is a memory or an SRAM or a flash memory or something. You can see the diffraction pattern at the bottom, sort of indicating it's a much smaller feature size. You get the colour pattern. Right, so here's what's left of the PCB after my various attempts to strip it off using a mixture of chemicals and heat. There's still one chip left there. It's too broken up to be worth trying to take off to look at. So on this side you've got sort of these three sort of pretty big chips. Slightly smaller one here. Most of the discretes are on this side. On this side, it's these small devices here are sort of discrete semiconductors, and some of these are the MOSFET type devices. And there's one sort of very large chip here, which was I think that memory device. There's a couple of medium-sized ones here, but I mean pretty much everything on this, every bit of silicon on this looks like it's custom. You probably noticed in a lot of standard silicon chip data sheets, a disclaimer saying not guaranteed for life support. So maybe if you're making critical life support equipment like this, your only choice is to make custom chips. But I mean the combination of just the design cost of all this lot, the development cost of the chips and all the approvals costs, the one-off cost of these things must be absolutely astronomical. But very interesting bit of tech, sort of quite different to most other bits of electronics, but obviously this thing is, literally lives depend on it, so it has to be reliable. There's almost certainly a certain amount of redundancy, triplication, self-test, maybe some self-checking type stuff going on here. But very impressive bit of tech. And this is some of these chips are dated like about 10 years ago, so be interesting to know what the current state of the art is. Although I suppose if you're doing custom chips for this sort of thing, you want to get as much life out of them as possible. So maybe they're still manufacturing with similar sort of devices. I mean, once you get down to a certain size, it probably doesn't really need to be that much smaller, and the size is probably dominated by the battery anyway. But interesting bit of tech. If anyone's got any other pacemakers or any other sort of implantable devices, I'd be very interested to take a look inside.